All right, so I've been trying to find a graphing calculator. I'm gonna have to probably use Desmos, so you might see some weirdness pausing later. So this section about velocity and rate of change. So we've already defined the instantaneous rate of change. That means the slope at one point is also called the derivative. So when we take the derivative, these are the exact same things that we've been doing in the last few lessons. So if we ask you, like, what's the instantaneous velocity? What's the instantaneous rate of change? We're asking you to just take the derivative. So if you're in physics class, that's the equation that they typically give you. So they say, here's the velocity, and then they start asking you questions about it. And calculus, we're giving you position, and that's what the S stands for. So S is position, and then when you take a derivative is when you get the velocity. So speed, you should have learned in physics probably if you guys are in there that speed is velocity without direction. So what that means is that if you take the absolute value of your velocity, that's the way you take off the direction, it's the same as speed. So if we took the derivative and I end up getting a velocity of -10, then its speed is a +10. And then acceleration is when you take the second derivative. So these are just vocab words here. So first derivative is called velocity, second derivative is called uh, the second derivative is the acceleration. The third derivative is called the jerk. We don't typically use it, but it is in some textbooks. So displacement, you've probably learned, is a change in y. So you're going to do y2 minus y1 over x2 minus x1 to find the displacement of it. So it's like the end minus the beginning, I think is how we phrase it in physics. Average velocity, that is just your slope formula. So if I say, what's your average velocity? Not instantaneous. Instantaneous velocity is a derivative. Average velocity is when you do y2 minus y1 over x2 minus x1. Right here, we've talked about this too, that 16t squared is gravity acting on an object in feet per second. If you do 4.9 t squared, that's just the meters per second. It's the same equation. So the first one right here, we want the rate of change of the area of a circle with respect to r. So first you need the area of a circle is pi r squared. So then just take the derivative. We're just going to say dA over dr. So that means I took the derivative of an a, the area, with respect to r, its radius. And then this derivative, pi is just a number, so you just leave the pi out here. And the derivative of r squared, sorry, it froze up on you guys. The derivative of r squared is 2r. So typically we would write that as 2 pi r. And then if it wants you to evaluate when r is 5, so you just plug 5 into the equation and we get out 10 pi. 10, plug in 10 in here and we get out 20. So we get 20 pi. The next one, dynamite blast propels it. The initial or the launch velocity right there. So here would be our equation because like your initial height would be 0 and then that was your velocity, take the antiderivative and stuff would get this. So how high up does a rock go? So that rock would go as high as its maximum. So a maximum in calculus happens, like if you think about it, I'm gonna draw you a picture here hopefully. So right here's the max. So that's when my velocity equals 0, right? So there's the slope right here is 0. So to figure out how this goes, and I know this is a quadratic and we could do like algebra 2, do it like find your vertex and stuff, but typically you can't just find a vertex on these questions. That's why I'm using an easier one to do this. So really you find the maximum of a graph, you find out where its velocity is 0. So you just take the derivative of this and we're going to set it equal to 0. So we're going to get, so this just means S, so the derivative equal to 0. So it's going to be 160 minus 32t, and I don't have a calculator on me, so let me get Desmos real quick. What did I do with my Desmos tab? So we're going to do 160 divided by 32, so we get 5. So t equals 5 here. And then what's the velocity and speed at a height of 256 degrees, going up and going back down? So first I need to figure out when we would have that height, and then I could take that answer, I'm going to plug it into the derivative here. I don't know why I keep zooming in and out, sorry. So what you need to do is do 256 equals 160t minus 16t squared. Rewrite that as 16t squared minus 160t plus 256 equals 0. I believe these are all divisible by 16. Let me check real quick. 256 divided by 16. Yeah, 16. So if I pull out my 16 here, I get t squared. That would be a 10t plus 16. That'd be a -8, and a -2. Let me make sure that the screen's still on here for you guys. Okay, good. So it happens when t is 8 and when t is 2. So that should make sense because when the velocity, so when the rocket's going up at 2 seconds, it hits it. And then when it comes back down at 8 seconds, it's hitting it again. And we know that the height is 5 and it's a parabola, so it's symmetrical. So that makes sense that those should be the two numbers. So then all you want to do is you want to plug 8 up here into the function. So let's see, we're going to do 160 minus 32 times, we'll do 2. 96, so it should be 96 in each direction. So going up, we get the 96 feet per second, and then coming down, it's just going to be a negative 96 feet per second. If you plug an 8 into that equation, you should get the negative. And then it wants the speed, so that's the velocity. So the speed is just the absolute value. So the speed each time is 96 feet per second. The acceleration is just the second derivative. So if this was the first derivative, the second derivative is just going to be negative 32. So I'm going to say a of t equals negative 32, which is what we know. Negative 32 feet per second squared is the acceleration due to gravity. So that is, it's always negative 32 feet per second squared. When we'll hit the ground, that's when your height's going to equal 0. So you can take your initial equation right here and set it equal to 0, 160t minus 16t squared, and you can solve that algebraically. And I feel like, let's see, if I take out 16t, that gives me a 10 minus t. So it's going to hit at 0 in 10 seconds. So 0 is when the initial blast happened, and then 10 seconds is there. So down here is just a bunch of vocab again that we talked about at the top, and I'm just going to give you a problem in order to try to do it. So remember, displacement is the difference of your y's, average velocity is just the slope, instantaneous is the derivative, acceleration is your second derivative. If I ask you when you changes directions, so you say, oh, when does this ball change directions? What you're going to do is you're going to take the derivative equal to 0, and then we're going to figure out what the movement is on that. And max and mins we just talked about is the derivative equal to 0. If they want the actual height of it, you'd plug that back into the original to get the height. So let's say find this first. So we're going to find all these things. Let's say from 0 to 2 seconds, or at 2 seconds for it, if it's like an at a point. So to find this displacement, plug in 0. So I plug in 0, I get out 1. Sorry if you can hear my kids screaming in the background. Let me see, I'm plugging 2 into there, so 3. I'm trying to get this so that it stays there. That's probably better for you. So 3 times 2 squared minus 4 times 2 plus 1. So I got out 5. So I plugged in 2 and I got out 5. I guess I could have done that without a calculator. I don't know what I was doing. So let's see. Then you just do, so displacement, you would just do 5 minus 1. So my displacement is 4 feet. So that's the displacement. All right, if I want to find the instantaneous velocity is just my derivative. So 6t minus 4. If I wanted it at like 2, you just plug in 2 here. So at 2, we'd say, you can write like this also. So instantaneous velocity would be 12 minus 4, so we get 8. And that would be like feet per second. Acceleration would be the next derivative. So my acceleration, that's a weird one. Let me make sure this is still on the screen for you guys. Okay. So the acceleration would just be this derivative, which is 6. And that would be feet per second squared. All right, so when we figure out when this changes direction, that means we take this derivative here, and I'm going to equal it to 0 and solve for t. So t is going to equal 2/3. So what it's telling us is that, and this is a parabola, so we know that the parabola, right, is like going down and it's shooting back up like that, and then the turning point's at its vertex. But this is what we're finding mathematically. So if you don't know, it looks like a parabola and that stuff, this is what we do. So we take a derivative equal to 0. So then you do 2/3 on a sign chart, and you plug into the derivative because we want to know what the velocity is doing. And that's important. You guys always forget. Plug it into the derivative. What is the velocity doing? So when I plug in 0 here, my velocity is negative. And when I plug in like 1 here, my velocity is positive. So that tells me that my particle is moving left from 0 to 2/3. So I'm going to write it down here. left from 0 is less than t, I guess technically less than or equal to, but, and then 2/3. And then it's going to be moving right when t is greater than 2/3. And it stopped at 2/3. Now, when we're talking about increasing and decreasing, we're actually going to include the 2/3, and I'll explain that at a different time right now. But so that's your left and right. So then your maximum just occurred at the 2/3. So our max is at 2/3. If they want the actual y value, we would plug that back into the original. Let me try to do that real quick for us. Times 2/3, and it looks like it's negative 1/3. And I could have done that wrong because I'm trying to use Desmos real quick. So the max, and so if they ask you for the maximum value, you should have learned this in pre-calc. The maximum value is actually just the negative 1/3. They ask you for the point, you get the point, stuff like that. So just make sure if we say, what's the maximum value, they're actually saying, what's the negative 1/3 is your answer. We don't have to do this example anymore. So hopefully the book questions in here, you might get stuck on a few of them. Don't forget that you have Slader. So go ahead and scan the book, look at their solutions in there and stuff, and see if that helps you. If not, you can always email me, ask me questions. I'll talk to you guys later.